13.2 Applications of the Ideal Gas Law. Applications of the Ideal Gas Law 13.2. Short lesson here. Density and molar mass. The molar volume of a gas is defined as the space that is occupied by 1 mole of gas. So the density of the gas is similar to the density of a solid or a liquid. So density is equal to the mass over volume. Okay, so to find the density of something, you take its mass, you divide it by its volume. So if you know the molar volume of something, you can utilize that to find its density. So here are just some equations. Now, don't let this formula fool you here. It looks kind of a lot more deceiving. All this is that molar volume. Okay, so remember what we said? V here, our volume, and then our N. Remember this N in this example, if we're asked to find the molar volume, we're assuming 1 mole of gas. Okay, but sometimes if you're given a mass ahead of time, you might have to find this N value using this formula here. Okay, so you might be finding that N value from here. So be aware how formulas interchange. That was the one thing I realized in university. It wasn't until in university when I figured out that when I finally started really understanding how formulas work with one another, and how when you see similar variables, you can combine different formulas together to help you solve the problems. Anyhow, so all gases have approximately 22.4 liters at STP. This is only if it's at STP conditions. Now, the molecular masses of different gases, however, are all different, which means that each gas has its own density and its own mass per unit of volume, right? Every gas is going to share its own specific density. Okay, so we've got here just a bunch of sample problems. In this first one here, really, I'm asking you to calculate the density. Okay, so we're utilizing the formula for density. Density is equal to mass over volume. Okay, but in order to do that, well, we need to find the number of moles. Okay, in this question. Once we did that, we're trying to find a nitrogen gas. Here's the molar mass of nitrogen gas. To find the mass, there it is. Okay, so we're trying to find the density. Now, density units. Now, here's the thing. We're being given 1 liter. Okay, so we're trying to find the density, and understand that the density is a mass per volume. But remember that per volume, per liter in this case. So we can assume that we have just 1 liter of gas as our sample. Okay, so understand that per unit, like that's why it's so important to. This is why I always stress utilizing units when you're doing your calculations, just because the more you utilize units when you're doing any calculation, the more hopefully the units make some sense. So when you think about a density unit, okay, and we think, okay, well, I've got grams per liter. Okay, there it is, grams per liter. Do I understand what this grams per liter means? This means that I might have some kind of mass for every 1 liter that I have of that gas. Okay, so again, if you need to really understand what these units mean to help you understand where some of the tricks lie in some of these questions. These questions are easy when I'm walking you through them. Now, when you're sitting on your own looking at a question and trying to solve it, if you don't understand what units are, what they mean, okay, you're not going to see these little subtleties like that. Okay, subtleties like up here. Actually, let me use a different color. up here, when I substituted 1 liter into the ideal gas law equation. Okay, nowhere in this question does it ask me for that my volume is 1 liter. But if I understand what my unit is, okay, I'm asking for my density in grams per liter. I am literally telling you, use 1 liter as your volume. Okay, so please, again, yeah, it's easy. It makes sense when I'm walking you through it, but that's why it's important that you don't utilize my answer keys as your crutch, but that you try to solve my problems and then refer to it to see, okay, where do I go wrong along the way? Okay. Next question here. Again, we're just kind of using the ideal gas law to find the number of moles. Okay, and we're utilizing here the molar mass of a gas because we want to try to identify which one of these gases is this question related to. And again, please go through these sample problems as I've detailed. These answer keys are all available to you on the Google Slides. And then finally here, here's probably one of the tougher questions in this unit, and this is because it goes back to Chapter 7, where we talk about empirical formulas. So understand that we could still utilize that stuff here in the latter chapters. Okay, so be aware with these questions. Don't be fooled. Don't be scared when you see really big questions. Understand that a lot of times, the one thing I know is that if a question gets longer than 3 sentences, students start to panic. In fact, even 3 sentences start to give 3 lines start to give some anxiety to students when you're answering these questions. Be aware that sometimes some of the lines are just kind of filler chemistry trivia with regards to what this question is implying. So don't be scared by the length of a question. Okay.
I hope you liked this video. If you did, do not be shy to hit that thumbs up button. And while you're clicking the thumbs up, click on that subscribe to stay tuned to my new videos. Thanks for watching.